Hi, my name is Norman and it's Christmas time. Well, at least at the time of recording, it's the 20th of December to be precise, and my brother still needs a present. He's been talking a little bit about the game he's currently enjoying. It's called Genshin Impact. I haven't played it myself. I don't really know much about the game besides that my brother enjoys it. And that enough was the trigger for me to decide to build one in-game weapon for him, because I thought, well, it's pretty cool to have, right? So the problem is that I have no idea about the game itself. I don't know exactly which weapon is good, which weapon is bad. I basically just Googled top weapon tier list, and then I took the one which looked the nicest. I chose to go with a weapon called
Aquila Favonia.
But because I'm really having trouble spelling that, I'm just gonna call it sword from now on. Looking at the stats, it looks pretty nice. It does have some kind of lifesteal mechanics thing, I don't know. Let's just hope that this weapon doesn't suck completely, but even if it sucks in-game, in real life, it's pretty cool. It's gonna be cool, I promise. So when we're talking about the sword, it's really hard to find references. There's one store where this image is actually from, Cosplay. Where you can buy this thing ready-made out of PVC foam, I think. Also looking at in-game footage, you can't really see because everything is moving so fast and flashing everything. If you don't know the game, you can't really tell what's going on. While it sucks to not have any references, it's also a blessing, let's say, because you don't need to be very detailed about everything, because the only important thing is, well, the glowing blade here and these wings here, and then you're gonna recognize the weapon. So for me, it's a very good thing that it's hard to find references because, well, I'm not very good at 3D modeling. For sure, I can design cases and whatnot, but when it comes to looking nice and tidy and clean and all that, yeah, that's where my skills end right there. Still, I designed it in Fusion, probably not very suitable software for that, but I think it ended up being pretty nice, right? So let's just, whoop. So this is the 3D model, and I think I did a pretty good job. Maybe one thing to notice is that I designed only one half, except for the edge of the blade, because this is gonna be printed the other way. By designing only one half, you're gonna save a lot of work because you're not gonna do half the work. But also, you instantly have a flat surface where you can print your model. That's pretty cool, right? So the blade is split into 5 segments so that it's printable, because my printer is not that large, and so on. So same as the handle and the wing here, those are also separate. So that's pretty neat, I think. Also looking here at the insides, this is where the magic happens. You can tell there is a hollow room for electronics. So we're gonna add some lighting and all that. But we're gonna save that for later. For now, we just need to know segments and print it halfway down, because that's gonna make your life a lot easier. Boop. And here we are, segments. This one is fresh off the printer, still warm actually. And those are printed in black PETG for no other reason than I had 6 kilograms of it lying around. Of course, we're not gonna need that much, but that's the most abundant material at the moment here in my storage. And also the color, it doesn't really matter because I'm gonna paint it later anyway. So to be able to pull this off in time, before Christmas Eve, I decreased the printing quality and increased the nozzle size, which also decreases the printing quality. So 0.25 millimeter layer height, 0.8 millimeter nozzle diameter. This piece prints in about 1 hour. So yeah, this is 5 hours printing time, which is great. Of course, the larger pieces in the back take a little bit longer. But basically, I'm able to print this entire sword within just, 3 days and nights. Not continuous, of course, but whenever I have the time, I start a new print. The quality with this doesn't really matter because I need to use a lot of filler anyway for everywhere. Of course, you got your layer steps. Yeah, that's something you can't avoid. Yeah, I thought I'm gonna use filler anyway, so I might as well just save a little bit of time. I think the system here is quite self-explanatory. It's a puzzle, if it fits, it's correct. If it doesn't fit, it's not correct. That simple, right? Yeah, not only these notches here will help with alignment, also, of course, they're gonna add a little bit of strength to the entire structure. But because, well, there's still a little bit of wiggle room here, actually quite a lot, you're gonna use a little trick here. Yeah, you could go with epoxy, which would be able to fill up these gaps in no time, or in a lot of time, but without any problems. I decided to go with this special glue here. This glue is very good for this type because it dries hard. So the Uhu brand has different types of glues and they're all very good, but this one dries rubbery. You know, it gets soft, you can press it with a nail and all that. That's something you do not want on your sword, probably. And this one is drying hard, which is awesome. It's perfect for us. Okay, as I mentioned before, here, huge gap, right? So to fill this gap up, there's a very simple trick with glue, especially with this liquid type of glue. You apply a thin layer and then you wait. Well, you do not actively wait, you can passively wait by applying a thin layer everywhere. Now it had time to dry. You can already see it's only glossy on some places, but it's still tacky. So now we can apply a thicker coat and then press them together. Boop. So that way, you can see here, there's a larger gap because it's just gonna add a little bit more. That way you're gonna have a really strong bond and fill up all those gaps in between. And then it's just rinse and repeat. That's the right one, yeah. So before we slowly get this thing out of the way, I like to come back with the glue and just fill up those gaps here in between. And then, you know, just spread it with your finger. This glue dries actually pretty quickly. This needs to set about 10 minutes until you're able to move it. It's just gonna wait, right? Okay, 10 minutes have passed. Let me just, you know, move this very carefully aside. Yeah, okay, wait a second. Here, I finished the left half yesterday already, and you know, you can tell it's really large. It's all glued up already. I think it actually works pretty great. It's quite top heavy because the handle is thin and all that. And then here in the front you got a lot of material ongoing. But overall, it works surprisingly well. I'm quite worried about this bond here. These are okay, but here, there's where all the weight of the blade is sitting on a very tiny contact surface here. Anyway, I was talking about the electronics and I came well prepared. Here is a prototype. And I completely forgot to turn on the lights, I just realized. Look at that. Okay, all right, here's the prototype, right? So I have good news and bad news. The bad news are I had to build this off camera to know what components I need, to know how much space I'm gonna need for that. But the good news is that this thing here, I don't know, only sort of works. It's very hard to reach all the cables underneath that sensor here. And yeah, that's why we're gonna redo it. We got a prototype and we're gonna do it again, so you're gonna see how it works. First, I'm gonna demonstrate. I'm gonna start with the battery. I salvaged that from a power bank. Of course, also off camera, but here's a little reenactment of how it looked like. Open. This is a power cell from a power bank. You know, this entire circuit, or most of the parts here actually require 5 volts. This one delivers 4.07, which is actually not enough, but somewhat it works, which is cool. Yeah, power goes in here. On-off switch goes in here. LED goes in here. And then we can turn it on. Takes some time to boot up, probably because of the under voltage. And then it glows. I don't know if you can tell on camera, but it's sort of animated, of course. I actually reused part of the code from the Infinity mirror mask I did a few years back, and yeah, it just works like a charm, right? I'm not entirely sure how much Canon this is, if it glows differently along the edge, but I thought it would be pretty cool to have. Also, I have these addressable LEDs and I want to use them. Could have just used regular LEDs otherwise. Yeah, we're gonna have an animation here. And it's all battery powered, if you don't wheel it around. This is a gyroscopic sensor, so it detects movement and acceleration and all that. Actually only acceleration and orientation. But for some reason it doesn't work on battery power. Let me just, you know, turn that off so it's not battery powered at the moment. I'm gonna plug that in and turn it on. And turn that on. I think you require both. You don't need the battery at the moment, so you can see it's now powered by USB. And now you can see when you move it, it's gonna light up, which is pretty cool. I mean, it's also very dangerous to encourage people to, you know, wave around the sword, but it's gonna be a whole lot more fun that way. Yeah, I have no idea why that gyroscopic sensor doesn't work on battery power. Actually, this thing is the only thing rated to work between 3.7 and 5 volts. So it's alright with that, as far as I know. My guess is that something's wrong with the wiring underneath the sensor here, which is tightly soldered in and not easily removed. And I'm just hoping that it's gonna be fixed when I redo all of that. So if I redo this and the gyroscope isn't working, in that case, I'm just not gonna care. Because, you know, it's almost Christmas and I gotta finish this in time. So I'm just gonna hope that everything works and then keep my fingers crossed. And if it doesn't work, it's still gonna glow and have the glow animation and all that. So it's still gonna be cool, but let's just hope that it's gonna be really cool, right? Wiggle, wiggle, wiggle. So before we actually start building, let's just talk through how this entire thing is gonna work. If you just don't care and if you just want to know if it works, you can just jump ahead to this timestamp. But if you want to know how it works, just stick around with me at the moment. In the middle, we have the power supply. Let's just mark it like so. The power supply is this little unit here. It has micro USB. It can actually charge the battery and of course also discharge the battery. Well, it has some protection for the battery, so it prevents the battery from 100% discharge. This module is pretty cool. It does support micro USB power in or you know, two wires. The power supply will be powering everything. Big surprise here. It's connected to the battery itself. I'm just gonna draw a really cool battery like so. This is also with some zippy zaps. The battery is going to be wired to the power supply. That way, this power supply can charge and discharge the battery. And now we're gonna get to the more complicated part. We are going to make a so-called power bus, which means we're gonna have voltage here, and we're gonna have ground here. One difference is though that, you know, to turn that thing off and on, we will need a little switch right here. So this is the switch, that thing, in case you didn't know what a switch is. This is going to, you know, close the current loop and enable or disable everything. To prevent power spikes, we're gonna add one of those capacitors. And I'm just going with the one I have lying around. I'm not sure if this is good or not, but I know that capacitors are going to save the battery from current spikes and also everything else probably, I don't know. So we're gonna add one capacitor. I'm not sure exactly where, but I would be adding it here probably. Yeah, I'm not an electrician or not. This makes absolutely no sense, but just C for a capacitor, right? So yeah, there's probably a technical drawing symbol for that, but I don't know it. So now we got our three components, right? We got the Arduino Nano, we got the gyroscopic sensor, GY5 to 1, I think. And we got, of course, the LEDs. So 3 things to power. So let's move that all down here so that we got a little bit more space up there. We got, let's just draw a very quick microchip here so that everybody knows this is the Arduino Nano. Cool. Then we have the gyroscopic sensor, so we're gonna draw a gyroscope, 3-axis gyroscope thing, probably. Okay. And last but not least, we got the W2. I think that's how the LEDs are called. I'm just gonna draw an LED. And these things all need power, right? That's why we got the power bus here. It doesn't make much sense on the drawing here, but having a power bus in real life is gonna make your life a whole lot easier. So actually, it's fairly simple. We're just gonna add the ground to all these things, and then we're gonna add 5 volts also to all these things. That easy. And when you turn this switch on and off, you're gonna close the current or you're gonna open it. Only thing to know is that, of course, the gyroscope also will need to send its data back to the Arduino Nano. For that, we need SDA and SCL, a serial connection. Yeah, so it requires 2 wires going to the Nano. Also, something which I struggled to learn early when beginning with all the Arduino stuff, not all pins are made equal. So the SDA and SCL wires are supposed to go into the SDA and SCL pins. And funny enough, not every pin is capable of doing such things. I think for the Nano, here it's a 4 and a 5 pin. So we're just gonna write a 4, a 5. Yellow is SCL, goes to a 4. And the other one is SDA. I'm not sure, I'm gonna look that up later. Maybe that's total horse crap. For now, we're just gonna stick with it, right? And the next thing is that the Arduino, of course, also needs to tell the LEDs, which, wait, this is wrong. It's actually, the shorter one is ground and the longer one is voltage, I think. Oh man, this is gonna be embarrassing. So the Arduino needs to tell the LEDs which color to glow. So for that, you can actually almost use every pin. I think it's just required to be digital, I'm not sure. But I'm using digital pins because I have enough of those. They're less versatile than analog pins because everything a digital pin can do, an analog pin can also do, but an analog pin also does other things. So yeah, try to keep those analog pins free and not use them if you don't need them. It works with digital pins. And that's what we're gonna do. We're just gonna wire these LEDs up with the Arduino Nano to some random digital pin. In that case, it's digital 7, D7. That's how the communication works between Arduino and the LED strip. Yeah, okay, and that's basically it for the wiring. Now you know what every component is doing in here and how they're gonna look. Gyroscope, power supply, Arduino, capacitor, and JST sockets to make my life a little bit easier. So let's get building. So I finished the circuit. Of course, it looks really ugly, but seriously, I don't care. It's going to be hidden inside the sword later. So we got the on-off switch. We got one single LED, which is going to sit. Give me a second. Well, there's a little gem on the bottom of the sword here, and the LED is going to sit right there. It has 4 wires coming out: power, data in, ground, and data out. So that way I can, route these LEDs in series as they're meant to be. I added more LEDs to accommodate for the length of the blade. I tested if the battery actually can support that many LEDs. It does. Unfortunately, the gyroscope still didn't work on battery power, so I just removed it to keep power consumption low. Startup time sped up a little bit, but not too much. That's unfortunate, but I think it's alright, click, 1, 2. 2 seconds, it's okay. I also tested charging module down here. It does charge the battery, and that's probably also very good, right? So now that we know that the electronics are all working, we can actually put them into the sword. But I just realized it makes no sense to put in the electronics at the moment, because we got still 2 or 1.5 problems to address. I'm generally concerned about, the seams here with the glue. I think they're actually pretty strong, but still, all the weight is here on those seams, and I don't trust them. Yeah, this is the left half, which was printed before I even started the video. Then I realized we got this problem, so I added some crevices on the right half to put in, where are those? Some of those. So these carbon fiber rods, of course, going to cut them down to size. They're going to support all those glue seams. And also, of course, I mentioned my concerns about that seam, especially because this is going to hold the entire weight of the blade. And the problem with that is actually that's where the charging USB cable is supposed to go. And that's a problem, because that here I can't support the weight with carbon fiber. That's what I thought initially, but I have an idea. So this charging module here does not only support micro USB in, it also does support, you can see it here on the outside, it's in plus and in minus, so you can also wire it up directly. I'm just going to assume that this works, hopefully. So what we're going to do is we're going to make the channel here for the cable a little bit larger so that this carbon fiber rod fits in. Then we're going to cut off this end of the cable so that we can feed the cable through the rod and then wire it up directly to the power supply or charging unit here. So that way we can add a whole lot of strength into the handle and still charge the entire thing. Yeah, we're going to make a little bit of dirt. I set the tolerances a little bit too low. So this one especially is not going to work. So we're going to increase the size of all those holes. Of course, on the left half, we need to add them in the first place. So a lot of digging, a lot of whatever I'm going to use. So let's make some dirt. all those parts inserted, and I think we're all ready to turn this thing on, right? So here's the switch. Maybe you gotta look at the nice side, right? Just see how cool it is. And I have absolutely zero trust issues, because here's a carbon fiber tube and there are carbon fiber tubes reinforcing everything. Funny thing, the entire sword behaves like a regular sword. It's wobbling around. Also, it's actually fairly balanced, which is pretty cool. Yeah, it's gonna be very easy to hang on the wall. Maybe just use a nail, or I'm gonna print something. I'm not sure yet. It's working, more or less, because I added one LED in the front here, which is not working for some reason. I replaced it twice already. The code is also correct. Checked it. It doesn't want to run, so yeah, I'm just gonna leave it as is, right? Pretty nice, I'm happy. So last thing to do, well, there are a lot of things to do actually, but next thing to do is attaching the other half here. That's gonna be a puzzle. I need to figure out where to make space so that all those parts fit together nicely. And then we have a sword, which is actually pretty heavy, but it's gonna be really good. In case you wanted to know how many clamps you're gonna need for this build, the answer is yes. Of course, I understand not everybody has that many clamps. If you don't have that many clamps at home, I suggest you just glue them down by segment. To be honest, that's also the way I should have done that, because it's a lot easier to, you know, align one segment by segment instead of aligning all of them at once. But I somehow sort of managed. I'm going to show you in a second. Here it is, and you can tell there are huge gaps in between, especially where the electronics are, but everything works, so yeah, I don't care about those gaps. We're gonna close them up now, and we're gonna fill in all this ugly support on this side. We're gonna fill in the gaps here in the back and everywhere, and hopefully it's gonna look smooth afterwards. Well guys, I got bad news. Unfortunately, the footage of me painting the sword, so the most satisfying part of this entire build, got lost for some reason. I think I accidentally formatted the SD card before, you know, copying the footage. Yeah, that's kind of a bummer, I'm very sorry, but the show must go on, so we're just gonna continue with the footage after painting the sword. Okay, here it is. Yeah, it's currently drying. I don't want to move it, and I'm just gonna leave it here as is. We're gonna talk about it in a second. So with pieces like those, of course, presentation is also very important. So I was thinking a lot about how do you mount this thing to the wall, or having a stand or whatnot. Earlier I mentioned that, well, the blade or the entire sword is fairly balanced, so you could actually hang it here in the back by a hook. But of course that doesn't look very nice, and also if you knock it, it's gonna swing around and all that. So I was thinking about having a 2-point contact here. All those things, yeah, they didn't really work for me, and then it hit me. I was thinking broomstick. So I salvaged this thing here from my broomstick hanger, if that's a thing, right? This is a very cheap piece. Basically, you can take your broomstick, imagine this is a broomstick, and then you can just click it in and then it's gonna hang. It works surprisingly well with the sword. I already tried it beforehand. It's very neat, it's clean, it's tidy, and if you don't want to hang the sword there, you can hang your broomstick. Very handy. Only problem is that this thing is a little bit too close to the wall, because the wings are obviously going to touch the wall then. So what we're going to do, well, I already did that. I printed a little spacer. It's actually self-adhesive, but the adhesion went lost when I removed it from the wall. So what we're going to do is we're just going to cut it out and help with the adhesion problem a little bit. Move this out of the way. We're just going to take a little bit more glue, of course. In case you remember, this thing was almost full when we started the video here. So yeah, you're going to need lots of glue. So again, clamp it down. I really think the broomstick hanger here is one of the best solutions because the blade is balanced and then it's going to balance out itself. So it's just going to hang here and hang straight. This is really cool. So now I'm going to use the hair blow a little bit more to get this thing ready. Then we still got the handle to do. As you can see, I didn't bother really much to paint it, to completely paint it for a reason. So we need to tackle that once the paint is dry. And then we're done, sort of. I think it's not completely dried, but it's completely awesome. I was thinking a lot about the handle, especially because, you know, on the picture, the one reference picture I had, you can clearly see it's made out of the same material as the golden stuff. Naturally, I should also paint it golden, right? But I thought, this is acrylic paint, it's not very durable. Yeah, I don't want this thing to be just, you know, decoration. I also want this to be a toy, maybe even for a cosplay one day. I don't know, my brother's not that much into cosplaying, but who knows? So I want people to see this and think, yeah, I want to grab it and swing it around. Having a delicate paint in the handle is definitely not going to help with that, right? Instead, we're going to use tape. This is a special type of tape. It's sort of a mesh built in. I'm not quite sure if I'm going to go with the white or with the black. White would be more to Canon, but black would be less dirty after a while, right? I think I'm just going to go with the white because it just matches the look. And application, you guessed it, is pretty straightforward actually. Just going to take the tape and wrap it around. Yeah, that's actually, wow, it feels great. So, here we are. That's so cool. There you have it. Yeah, it's really about time we literally wrap this up because, yeah, I gotta be at my parents' in 1.5 hours. Yeah, I really wish I could have spent more time on the paint job and on the finish. Yeah, I know Christmas doesn't come by surprise. I could have just started earlier, but I didn't. I think there's a lot of room for improvement here. All of this doesn't really matter. I think it still looks very great also from up close. Once you turn on the lights, seriously, nobody's gonna care anyway, right? It's so amazing. See, look at that. So you got this little gemstone here in the handle and the entire glowing blade, and I can swing it confidently around without, I'm not worrying at all. I'm not worried at all about the stability here, but overall I'm actually really satisfied how it turned out. I hope my brother's gonna like it. Oh no, we lost a couple LEDs in the front again. I don't know what happened. Hopefully nobody's gonna notice. God damn it. That's annoying. How? Is it a voltage problem? I'm not entirely sure. However, this is a problem for another time. So that being said, I hope you guys had a very nice Christmas. I'm going to have a very nice Christmas, hopefully. And see you guys in the next one. Bye bye. So I spent a wonderful Christmas evening together with my family. My brother really liked the sword, and I'm also kind of relieved that he told me that the sword is not total crap in game. So it's a good thing, right? But you guys know what's really cool? Actually, my brother dropped the sword in game shortly after Christmas. Like, what are the odds? It's a very rare weapon, and he got the weapon in game literally like 3 days after he got it in real life. So that's a really cool coincidence, and I think that makes the sword even more special. So I hope you guys enjoyed watching the video, and again, see you in the next one. Bye bye.